Hello everyone. In this video, we will see another example of solving an integral, double integral by changing the order of integration. So this is your integral. So in the current integral, the order of integration is, the current order is dx dy. Means first you are integrating with respect to x and then with respect to y. And the limits of integration, the current integral is, these are the limits for x, these are for y. So x varies from 1 to x equal to root of y, and y varies from 1 to y is equal to 4. Okay, now to change the order of integration, what we need, we assume that the new order, not assume, we know that the new order should be dy dx. First, we should integrate with respect to y and then with respect to x. Okay, and for that, we need the limits. So to find the limits, what we need to do, we need to draw the graph for this limits. So x equal to 1, y equal to 1, y equal to 4. These are straight lines that you can easily plot. For this one, you need to get the set of points to plot. Okay. So what you are having x equal to root of y. So let's prepare a table to get the values on this curve. So we make a table for the values of x and y. Now since here x is in terms of y, we substitute the value of y to get the value of x. So suppose I substitute y 0. So what we will get? X equal to root of 0, which is 0. I recommend here using the value of y, which gives you the, which are the perfect squares. So to avoid the decimal, because you are not going to draw the figure on a proper graph. So approximating decimal may give you a wrong area. So it is recommended to use the values of y, which gives you the perfect square. Like you know that after that you have 1. At 1, you will have the value 1. At 4, you will have the value as root of y as, actually it will, root of 4 will be plus and minus 2, but we are taking only the positive values. Because here, the values for y are only in the first quadrant. So let's draw this graph. Okay, let's take more points. Maybe it's not sufficient. Let's take one more point. So if it is 9, we'll take it as 3. So the points on this curve is 0, 0, 1, 1, 2, 4, 3, 9. Because always we write x first and then y. So drawing it on the graph, let's draw the y-axis and the x-axis. So this is x-axis, this is your y-axis. At x-axis, we know that y is 0. At y-axis, we know that x is 0. Okay, now we will plot the points. I have adjusted the graph here because we need the value of y a bit higher till 4. So let's say it's 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, similarly, let's take the value of x here. Say 1, 2, 3, 4, 5. Okay, we will look at this point if we need to substitute it or not. So x equal 1. At this point, x is 1. So it will be a straight line through here. Okay, x equal to 1 done. Y equal to 1 will be a straight line parallel to x-axis. Y equal to 4. Again, at this point, straight line parallel to x-axis. Y equal to 4. Now for be done with this, x equal to root y. Here we have the point 0, 0. We have the point 1, 1. We have 2, 4. When x is 2, y is 4. It will be somewhere here. Let's join these points. So clearly this curve x equal to root y, it's not a straight line. It will be a curve. Okay. Now we have to check where is our region R. This is our region R. So we need to check where it is. So x varies from 1 to root y. So it means x is varying from 1. This is the point where x is 1. This line to root of y. Okay. And such arrows. Such arrows varies from where? Y equal to 1 to y equal to 4. Y equal to 1 is here. It starts from down till up. Okay. So this is your region R. You have to be very careful when you are deciding the region of integration. Okay, because if you make a mistake here, suppose in place of this, if you select this as a region R, everything goes wrong. Okay, so pay attention what is given. So it's easy. Start with the first limits of integration. X equal to 1 here, x equal to root y. So along this line. So, and y equal to 1 to 4. So 1 to 4. So this is going to be your region. Now, this is horizontal movement, right? Now, new order of integration, we want dy first. So it means first we should move vertically. Okay. So vertically, if we look, it starts from, like, in this region starts from any curve which is moving from down to up. From down till up. Okay. So this is your vertical movement. Now, on this vertical movement, what is this at this point? Vertically means we are changing y. Okay, y-axis. Here, what is the value of y? 4. You need the value of y here. You know that x is equal to root y. You need y. So what you will do? You will take square of both sides. So you get the value of y as x squared. So at this point, you can say y is equal to x squared. So the new limits will be y varying from x squared to y equal to where? To a point on this line where y is 4. Okay. And then the limits for x. X is from here to maximum here. From this extreme to this extreme. Here x is 1. And what is the value of x here at this point? You see here, this is x equal to 2 because this is the point 2 comma 4. So x varies from 1 to x equal to 4. So your changed order of integration for this integral will be, let me write it here, double integral. We write the function x squared plus y, the changed order dy dx, y from x squared till 4, and x is from 1 to 4. Okay, let's solve this integral. So to work on this, first we solve this innermost integral. Okay, so let's write it down. Integral x squared to 4 x squared plus y dy. Now you see here the addition sign. Okay, you are integrating with respect to variable y and constant is x. So you have a term of y to integrate here, but here no y term. So in this case, what you will be doing, you will multiply by y. So x squared you keep same and you integrate 1 that gives you y. Okay, plus the integral of y, it will be y squared over 2. Note that if there is no positive sign, there is no sign like plus or minus, it's just multiplication. In that case, you don't need to add this y. Okay, so let's substitute the values. Y is from x squared to y equal to 4. So this gives you, like, first you will replace y by 4, these two y's by 4, and then by x power 2, giving you x squared 4 plus 4 square over 2 minus x square times x square plus x power 2 and power 2 over 2. Okay, so these are the limits at x equal for at y equal 4 and here at y equal to x square. Simplify. So on simplification, it will give you this value. Okay, so you see that you integrate with respect to y, so there is no y term. Okay, so let's now substitute this value in the other integrals. It is 1 to 4, 4x squared plus 8 minus 3 by 2 x power 4. Integrate with respect to x. It is a simple definite integral for the function of one variable. So when you integrate it, you will get 4 x cube over 3 plus 8x minus 3 by 2 x power 5 over 5. Okay, and the limits are from 1 to 4. So now you can simplify and get your final answer. So you can simplify this limit and get the final answer by using the calculator. Okay, so these are the limits when you substitute x equal to 4 and x equals to 1, you will get this value. What we did, we just replaced this x. Okay, let's take one more example and I feel that after that it will be clear for you. Now, you have from 0 to 3, y by 3 over to 1 over 1 plus x squared dx dy. So here your order of integration is dx dy. The limits for x is this and for y this. So the current order is dx dy. Limits are for x. Yeah, these are the limits for x. X equal to y over 3, x equal to 1. And y equal to 0 to y equal to 3. So again, you have to plot the region R. These are the limits, give you the region R. To change the order of integration, plot this. Now, all these are straight lines, okay? So, for this x equal to y over 3, you have to prepare a table to get the values, okay? So, let's take here x, here y. So, if y is 0, x is 0. Again, here I'll recommend to use the value that gives you, well, those values of y that gives you non-decimal value of x. It's easier for you to plot. For instance, choose y to be 3. So you'll have 3 divide 3. This is 1. Choose y to be, say, 6. It gives you 2. So it will be easier for you to plot the points, say 0, 0, 1, 3, 2, 6, and so on. 2 points are sufficient to draw in that line. Okay, so let's draw the graph. So the graph will be, this is, let's say, y-axis. Okay, and say this is your x-axis. X here y. Which points you want on x-axis? You want it till 2. See, 1, 2. Let me put till 3 and 4. For y-axis, you need till 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Okay, somewhere here. Now, first point is 0, 0. See, the 1 should be somewhere here. Okay, this is your point 1. Then, next point is 1, 3. At x equal to 1, y is 3. So, it will be somewhere here. 2, 6, somewhere here. Okay, so join these points. Okay, so this is your line x is equal to y over 3. This is done. X equal to 1. This is the point where x is equal to 1. So straight line. It should intersect this point. You know why? Because what's the coordinate of this point? 1, 3. This point is 2, 6. Okay, and this was 0, 0. X equal to 1 is done. Y equal to 0 is nothing but your x-axis. Y equal to 3 is here. This is y equal to 3. Now to identify where is your region R, what you will check? Check the value of x. X varies from y over 3. It means point on this line. This is y over 3. So x varies from point on this line to x equal to 1. This is x equal to 1. So here. Okay. And then y varies from 0 to 3. So this is your region R. This is your region R. So order is dx dy. So it means first movement is horizontal. You want the changed order to be dy dx. So it means you want the vertical motion. So for that, vertical motion because you want to change first the variation in y. So y starts from here to up on this line. Okay, this this is the variation. So here, what is the value of y? 0 because x-axis. And this point, what is the value of y? If x is equal to y over 3, how you will get y? Just multiply both sides by 3. Let's get cancelled. So you'll get y is equal to 3x. So this line y is equal to 3x. Okay. So the limits for the new order of integration will be y equal to 0 to y equal to 3x. Now, what are the limits for x? Since this is your region, check the extreme. So here x is 0 and here x is 1. So x varies from 0 to 1. So your order of, after changing the order of integration, your integral become 1 over 1 plus x square dy dx. Yes, limits for y here. 0 to 3x and here from 0 to 1. So if you look at this integral, see here you would have to use like the tan inverse rule. But here you don't have to use it because you will be integrating this inner integral first. Okay, by considering x as a constant. Let's see quickly how to solve this. So integrating this, so this entire term, there is no y, it is a constant. So what will be the integral? Yes, it will be 1 over 1 plus x square. Integral will be y from 0 to 3x. So this will be 1 plus 1 plus x square, 3x minus 0. Or you'll have 3x over 1 plus x square. So you see here no y term. Now, completing this integral, what you will get? Integral 0 to 1, 3x over 1 plus x square dx. Here it's a quotient of two terms, not possible to combine them together. So again we look for substitution or integration by parts. Let's work with substitution first. So what term you are having? Suppose you use 3x as substitution, what you will get the derivative? 3, which is not the other function. So this substitution doesn't work. So let's go for the other substitution. Du, sorry, u equal the denominator 1 plus x square. So du by dx, what you will get? 2x. So yes, you are getting a function which is available here. So let's see how it works. Du over 2x is equal to dx. Using these values here in our integral 3x over 1 plus x square dx becomes integral 3x same over u into du over 2x. Since you are seeing two variables, you have to cancel the variable here. Okay, so this gives you 3 by 2 integral of 1 over u du. which gives you 3 by 2 ln of u. Okay. Now, back substituting the value, it gives you 3 by 2 ln of mod of 1 plus x squared. Since it's an indefinite integral, you should add the cost of integration. Now, let's come back to your question. It's 0 to 1, 3x over 1 plus x squared dx. This becomes 3 by 2 ln of 1 plus x squared. Limits for x is from 0 to 1. So just replace the value of x here by 1 and 0. You will get your final answer. Okay. So this will be 3 by 2 ln of 2 minus ln of 1. Ln of 1 is 0. So it is 3 by 2 ln of 2. Okay.